Good. So as I mentioned before, in order to find the tutorials, once you go to your module, you need to go to the Design Communication and 3D CAD Modeling, and you will go with the Parametric Modeling Techniques. And if you go to the tutorial section in here, tutorial files and NX models in here, so always upload the PowerPoint that we are using. So for today, it's a chapter 6 that we are going to work with. And what we're gonna discuss, we're gonna discuss how we can create the whole features, groove features, slot, ribs, and chamfers and edge blends. So these two, we'll see whether actually we have time to do that. If not, we will do next session. And it will tell you how we'll be able to create every single of those in here. And what I'm gonna do, I'm gonna show it to you. But basically, if in case you wanna do it at your own, of course, if this video is recorded, you can go through it, but also you can go through the presentation file to see how actually it's been done. Good. So let me open the Siemens NX. And in here, I'm gonna create a new file. So if you remember, in order to create a new file, we used to go to new. While we are in modeling, I will go with the model. We'll make sure to name my model and save it in my local drive because I'm connected to my actual machine university, so that's fine. If I'm gonna save it in C drive, I'll make sure you save it in your H drive and click OK. Good. So let me create a box first. In order to create a box, I need to start sketching. And I need to choose a plane. I'm happy with the X and Y. And let me make a rectangle with the 150. And once I finish the sketch, I'll go to the extrude, choose the curve where I want to do the extrude. And let me extrude it for the length of 100. Okay. Good. Let's say we have, this design. I'm gonna put some, create some holes on top of that. So next to the extrude, we have hole. We already, covered extrude. We already covered revolve, and now we're gonna go with the hole. So if I go to the hole, with the holes, you need to create and separate the sketch, or basically you need to specify a point. And this is what I actually is saying. So I just need to choose a plane that I want to have that point, and let's see what happens. Let me choose that plane. It would ask me, do you want to choose the face of that extrude as a plane? And I will say yes. And if I zoom in, it automatically created a point for me. And what I just need to do, I just need to escape, press on escape. Otherwise, it will create a new point for me. And use these dimensions that automatically done it for me. Or of course, what I can do, I can just start dimensioning them. But I'm gonna use those. I can either, so one of them I use this one, the other one I use the rapid dimensioning. Let's say I'm gonna bring this one closer to, this one is 32. Let's bring it closer to that place. I will do 10. And here, of course, I can either use this one, or I can go with the rapid dimensioning, and I will just put a dimension between these two. It's the same things, basically. And let me bring it inside. I'm gonna put it 25. Okay. That's it. Let me increase that one from the 10 as well to 25. Okay. And now I will just click on the finish. So you see automatically created a hole for me. And what I need to do, I need to define the end of the hole. So you can go with a simple, which I'm gonna do right now, and then I will talk about the rest of the options that I have there. And so in here, you would be able to define the diameter of it. So let me change this one to 40. And what you see there, that diameter on the top will change. So I'm gonna bring it back to the 25. I can define the depth of it. So let's change this one to the 20. And we'll see the depth of the hole will change. Let me put 40 here, for instance. You will see the depth of it. And then I have the cylinder bottom. So here you like a kind of cone nose. If you want, you can have the cylinder bottom. So the thing that actually, if you notice, that 40 which I gave is from the distance from the top to just there. But if I change that one to the cone tip, it becomes the height or depth from that surface to the end of the the nose of the tip of the cone that I have there. And I can change the angle of this one. For instance, this one is 100. Let's make it as the, I don't know, not 100. Let's make it as the, if I could do 0, let's do 0. You see it actually doesn't have any cone tip. And let me put the 100 here, for instance. You will see that actually it has the cone tip. So you're putting that one. But if I don't need it, so I would just put it as a 0. And it automatically, the Boolean is subtract because it's doing the cut. And I'll click on OK. And you can see the hole has been created for me. And even if I go to here, change this to the static wireframe, you see it actually the hole has existed there. Okay, so I'm gonna do it, I'm gonna repeat it one more time for you. So let me delete this one. So we'll go to the hole. The hole needs a plane. So I specify the plane I'm gonna use. It automatically say specify the point, but the point needs to be positioned in a plane. We'll just pick the plane that I'm gonna have that point, and it automatically created a point for me. In here, if I don't exist, if I just, let's say, click somewhere else, it automatically just add one point for me. So as many as I want. But if you want to cancel that one, you just close this. Even if you want to add another point, you can come here and add another point. So if you want to have the several holes with the same sort of diameter and length and depth. So let me get rid of this one because I don't need that. I don't need this one as well. I don't need this one as well. Okay, and in here it automatically put the dimension for me, but as I mentioned, you can always use the rapid dimensioning, the linear one, rapid one, to be able to position that point. But I'm gonna use that one. If you double click on the dimensions, you would be able to change them. So let's change this one to the 15, for instance. And let me change this one to the, let me see position of it. Okay, let me say change this one to 25 so it comes in the middle. And now I'm still in the positioning the point. If I click on the finish, it comes out of it, so it's already defined a point for me, and I can put the diameter in here. So I will put a diameter, I'll put the depth of it, how much depth I want, and what's the the tip angle I want. Let's put this time 100, and of course I can tell whether the cone tip is it that distance is from there to there. So basically this one become 40, and then you would have the cone tip, or I can change that one to the basic cone tip. So everything from the height to the bottom of it would have the depth of 40 millimeter. I'll click OK. At any time I want to change those informations, I can double click on the feature that I have. I would be able to come here and change those. Okay, so is it clear? Is it clear, and shall I move on? Okay, great, thank you. Good. So now let's see what other option we will see here. If I go and double click on the simple hole that I created, on the feature that I created here, you will see while I'm in the general hole, I have the other options. So let's change this one to the counter board. The counter board, once that actually you have a counter board on top of the design you will have, and you would have the options to be able to work with the counter board. So what I need to do over there, I need to give the seaboard diameter to diameter of top and a seaboard depth. So let me change this one because we put it quite close to the corner. Let me change this one. So if this one is 25, the seaboard diameter should be bigger than the diameter of this one. So I'm gonna make it as a 35. Let's see whether is it still okay or not. No, let me make it as a 30. Okay. Yeah. And the seaboard depth, what's the height of it? What's the depth of that seaboard? Let me change this one to 15, for instance. And the rest is like before. So you will have the main diameter of the hole and also the depth of it. And again, the cone tip. Let's change it to 0 this time. And I will click OK. It's quite close to the corner. That's why it's actually showing that error. It's okay. So let me go there. And let me go to the sketch section. So whenever you want to, edit a sketch section, you would be able to come and click there. Let me change this one and change that to the, let's say 40. Now finish. So now it should work fine. Now even I can increase this one. I can change it to 50. Let's bring this one to the 20 as well. And click OK. Let me see what was the issue. It should work fine. Let me do it again to see what was the issue, but it should work fine. So we go to holes. We are in general hole. I'm gonna choose the plane that I'm gonna specify the point there. And this is the point that I have here. So I click either close or press on escape because you already have one point and that's enough for you. You change these to position the point where you want. I'm gonna bring it to the middle. So I just change this one as a 50 and change this one to 25. A quick close. Finish the sketch. And in here, so from the simple, I'm gonna use the counter board. So I'm gonna give the dimension for it. Let's say seaboard diameter 38, the depth is 25. I'm happy with that. This one is okay. Everything is okay. Let me show the result first. Yes, and I'll click OK. And we see that actually it's been created, and it has the seaboard. So the diameter on the top with the diameter of the actual hole is different, and that's why we use the seaboard. And even if I come here, let me put it to the isometric. If I come and put it in the static wireframe, you see actually that's the seaboard, and that's the counterboard hole that we create. So it's the same as what you do as a general hole, but it's just the kind of it is different. Let's go ahead with the counterboard again, and now I'm gonna change that one to the countersunk. What you see here with the countersunk, you have the angular shape on the top as well, and then you have to have the C-sink. The C-sink is the main diameter on the top. So let me change this one to 45. and the angle you have, I'm gonna keep it as 90, but of course you can change that. And the same as before, and I will be able to click OK. And you see now I have the contest song hole in here. So I go to the static wireframe, you see it actually how I have the contest song there. Good. So let me go ahead and edit that one and change the contest song to the tapered. And you can see the tapered one, you give the diameter on the top and also you give the angle you want to have. So there, and I would be able to click OK. If I go there, you see it actually how I have the tapered hole. So now if you see, once we have the general hole, we have the 4 different types of the general hole. We have the simple, the contour board, the contour song, and the taper. So based on the design that you're gonna use, you will be able to modify that. So let me delete this one, and let's go and work with the other kinds of holes we have. So if I go there, you will see that I have the different type of the hole, but basically creating of them is the same as what we are doing. We'll be able to create the general hole, the drilling size hole. So it automatically, once you finish, it will show as a drill. You can have the screw clearance, you can have the threaded hole, you can have the series of hole that actually is a bunch of the holes next to each other. I'm gonna go and do a drill one. So all of them is like each other. And again, if you remember what you need to do, we need to specify the plane where we want to operate. And then it'll automatically create a point for me. So we'll close this one, that's fine for that. I'm gonna change the position of this one. Seems to be okay, but I'm gonna, yeah, 30 is okay. And even that one is 23 is okay. I will just finish the sketch. So I already have the point there. And in here, I would be able to just give the size of the drill that I have. And these are all standard sizes. You see that? So these are all standard available drills. Let's pick this one. And then the feet, you have 2 feet. It's exact one. So you're actually using the exact drill that is available into the market, or which is the foreman, or you can go with a custom. With a custom, you customize it. And so in the manufacturing side of the this module, I will talk about it. But basically, you as a manufacturer, you need to decide whether it's better to work with the standard tooling system or the customized one. The standard tooling system, of course, it would be cheaper for the manufacturer because they can get it from the market, and it's easier to manufacture as well. And also the other thing is that it's just you put that a kind of limitation for the designer, because the designer should go with only the one actually which is available to the market. Whereas if you're a bigger companies, for instance, the time that actually I was working in car manufacturers, they prefer to have their own kind of custom tooling systems. And the reason they go with that, because they can give more freedom to the designer, but also it's hard for the third parties to copy their design and also manufacture it. So it's really hard for the great market to be able to manufacture those. So in here, you as a designer, you should consider that if you change this one from the exact to the custom, which means that actually you have to inform and put it in your documentation that the customized tooling is required to create that hole. So let's go with the exact one. And the exact one, you automatically put the diameter based on that actually what's the drill is available for the size that you put, and just put the length of it, the depth of drill you're gonna have. And also at the end, you have the cone tip again, and also the cylindrical bottom. It's exactly like the the general hole. And if in case I don't want it, we'll just this one as a 0. But basically for the drill, they always have a kind of cone tip at the end. We'll click OK. If I come on the top, you will see that actually I have the drilling over there, and you will be able to see. It looks like that it's like a kind of normal hole, but once you work with the 2D drafting, which basically once you're gonna get the 2D sketch out of it, it automatically marks that this one has a drill. It's a drill, and that's why in here the feature shows the drill size hole, but it shows like a hole in here for you, but it would be automatically in the software marked as a drill, even if you are working with the computer-aided manufacturing, which is something we're gonna do in the second semester in TB2. Even the software automatically realizes that's a drill. So it's really important which hole you use, because this is how the software will find out whether it's a normal hole or whether it's kind of drilling. So let me go and create another one. And this one, I'm gonna go with the threaded hole, the same as this one. So we'll click the plane that I'm gonna have. It has specified the point for me. And if you see the dimension that it put, it based on the previous point. Of course, if you want to dimension it from the edge, you can go and use rapid dimension, and we'll say the distance between this one and this one. I want whatever, let's say 25.2, and the distance between this one and this one, let's say, you would be able to position it wherever you want. So you are not only limited to the position that is available, but basically because it's a second point, it will position it with the first point. I'll click finish. And now again, like that, so we'll have the different, threaded holes. These sizes, they're all standard sizes. So I'm gonna go with the M10, and these are the based on the radial engage. So basically, they actually, once we have the thread, what's the size of the the radial engage between each of those threads. And you can go with the one that actually software automatically find it out based on the standard thread you have, or of course you can put the custom size here. But of course I'll go with the normal one. And when you go with the normal one, you see that the tap drill diameter would be stopped. But if I go with a custom, you would be able to put the the drill diameter. What's the drilling diameter you have to put? I'm gonna go with the standard one. Even with the depth, so usually we go with the standard one. So either it's one diameter, so the depth of it would be the diameter that you have, which is 8.5, exact that one. 1.5 of diameter, 2 diameter, 3 times more of the diameter, or you can go with a custom, which you would be able to just give the depth of it, and the thread depth. So it is the depth between those, and now you would be able to give the whole dimension. So let me change this one. You will be able to understand me better. So let me change this one to the 40. This one will, and let me change this one to the 50. Like the previous one, I will have the cone tip. So let me remove that one, so I don't have anyone there. And that one, the depth type. So it's the between each thread. So what's the distance between those? And that's that one. So usually we go with the custom one. With the standard one. So I'm gonna go with the 1.5. So every time is a 1.5 of the thread I have, which I defined it there. I'll go with the one which is available. I will click OK. And you can see that's a threaded hole, but the kind of question usually the student would ask, they don't see a thread. So even in the assignment, once they will ask you to create a threaded hole, make sure you create a hole which has the threaded hole type. Don't do a thread. Thread I will teach you in other sessions, but actually you can see the thread. But here, it's the threaded hole, but it doesn't visualize it for you. So that's one of the things that actually the Siemens NX has. It doesn't show the threaded holes for you, but it's actually a threaded hole, and you would be able to see the threaded hole in here. But once you do a thread, once you actually created a thread, not a whole threaded hole, once you do the drafting, once you do the computer-aided machining, it will cause you a problem. So it's really important. In the part of the assignment which you have the threaded hole, make sure you use this type. And as I mentioned, so you have the different types. I don't go through them, but it's exactly each other. So if I go the clearance, you can see that actually you should define the screw size, and also then because that's the screw clearance, you should define to the machine how tight you want the hole be quite close with the screw you have. So if you go with a close, you can see the diameter is 10.5 because this one is 10. If I change it to the normal, it become 11, so 0.5 millimeter bigger. If I go with a loose, it will change it to 12, so 2 millimeter bigger than the screw that I have. Or of course, I can customize it as well. The rest of it is like the normal one. So I'm gonna go with the close fit and the depth, the cone tip you would be able to put. And if I click OK, I converted that hole from the threaded hole to the simple screw hole. And they all look like each other in the software, but basically the features are different, and you will be able to find it out that actually they are different once you are using those. Okay, so do you have any question for the holes, or do you want me to continue with the students as well? What can be the issue? Okay, so I have a question from one of your friends regarding the licensing issue in the software. So whenever you see that error, what you need to do, you need to go to this page called paging server, and you come here, you click on a stop to stop the software, and then you removed it. So I don't want to do that, but you click a stop and then remove it. And then what you need to do, you open the apps anywhere and then launch the app again. The reason you have that error because so every student, they would have access to one NX license, and because you're already connected to the virtual machine, and every time you connect with a different virtual machine which has a different IP address and MAC address, you no longer have access to your license, so you have to withdraw the license. And by removing it, you withdraw the license, and once you activate it again, it automatically allocated a new license to you. It's the same things for you if you're doing in campus. So if you go to the in campus, let's say to click on the NX, the software you have, and you click on remove. So when you change your computers from one lab to the other lab, or from the different rows, each of them, they have the different IP and MAC address, and you may have that issue. Good. So what we're gonna do now, we're gonna go ahead with the another feature. It's called groove. So in order to find the groove, you can go to the find command, and you can type groove here. And if I go on top of it, it tells me if I want to find it, I have to go to menu, insert, design features, and I need to go to the groove. Or of course, you can always search it on the command finder. So I'm going to use the one that actually I have in the command finder. And we have the three types of the groove: the rectangular one, the ball, and the one on a U groove. And basically, this is how the grooving would do it, cut through the design you have. Let's go with the rectangle. So I will pick the first one. And now it asks me where I want to have that groove. I'm gonna have it on the surface of this cylinder. So click OK. And it will ask me what's the groove diameter. So I can say the diameter I want. Yeah, this one is okay. So I will put 40, and the width of it, so I'll put 50, for instance. I'll click OK. You can see it automatically trying to locate that one for me based on the dimension that I gave and based on the height that I gave for it. What I need to do, I need to position the groove. Do you see that? It says position the groove. If I come here, this is where the software shows me what I need to do. It says select the target edge or OK to accept the initial position. That's the initial position. I'm gonna do a different positioning. So I'm gonna, let's say, from that edge to the edge of the groove that I have here. Now it asks me, okay, to put the dimension for you. So how much distance of these two edges do you want to have? And I'm gonna put it, because I'm gonna bring this one down, I'm gonna put it 30, so it comes down, and that's it. And I'll click cancel. And you can see it's like you kind of in a rectangular shape goes and cut the design that I have. So if I double click to that one, I can go to the feature dialog. I would be able to change my groove diameter and the width of it as well. So you can see that's the groove diameter and that's the width of it. So let me change this one to the 100. And if I click OK, so that one become 100. Let me do it again. So go with the feature dialog, and the groove diameter is that one. So I can change that one. Let's put it as the 20 this time. So make it narrower. Okay, you can see that one is 20. So these are all the dimensions we put. Right? We'll delete it again. And also edit position. If in case you want to edit position, you click the edit positioning, and then you would be able to change the dimension you have here. So you can either edit the dimension values. If you see that distance between this one and this one, I put 30. Let's put it as the 50. So it should automatically come up. You see that? So we can edit those. But let me delete it again, and I'm gonna create it for you one more time. So what you need to do, you need to go to the command, type groove. You would be able to find it in the menu, insert, design, feature, and groove. And you have the 3 different type of it. I'm gonna go with the rectangular one at the beginning. And then you need to select the placement face. Where do you want to have that groove? I'm gonna have on that face, and I'll put the groove diameter and a width of it as well. I'll click OK, and I need to position that one. So I'm gonna position it from that edge to this edge. I'm gonna change this one to, let's say, 30. And once everything's fine, I just either click on cancel or on escape, and that's a rectangular groove. Let's try another type of the groove. And now I'm gonna go with the ball end one. I choose where I want to operate. I put the groove diameter, the balling diameter as well. Let me change this one to the 30. And now I would be able to position it. I use that edge with this edge, and a distance I'm gonna put is 20. No, cancel. You see the difference between rectangular and the balling is like a ball goes through and cut that cylinder. Again, I'll repeat it one more time, but this time with a different groove. I'll go to the grooving. I'll go with the U groove this time. Choose where I want to operate, the face of that cylinder. I'll put the groove diameter, the width of it, and also the radius, because that one is a U shape. So it's a U, technically the inside of the U. I will use 2.5, whatever the software gave me. And now I would be able to position it. I will position from here to that edge. And I will change this one to 20, let's say. And you can see that's a U groove. The 2.5 that you put is the radius of this one. So you can see the rectangular one, the ball-shaped one, and the U groove one. The 3 different type of the grooves. Is it clear? Should I move on, or do you want me to repeat this one? If it's clear, please say yes, and I will move on. If you have a question, please press on no. So the next one I'm gonna teach is the slot feature. Let's type slot and let's see what do you see there. So you can see the one that actually we're using here, it's become a part of a legacy, which means that the Siemens NX decided to remove that from the main features. And the reason actually we have those, because basically with the slot, you can easily create it with a normal extrude, subtract, or cut. But of course, if you're using, or if you're coming from the SolidWorks or a more kind of industrial one, CATIA, they always have the slot. That's why they didn't remove it completely, but they just hide it. And this is why you see it as a kind of, legacy. Let's click on that, and you can see there is no other way you would be able to, find it. Of course, you can go to the menu, design feature, but it's currently hidden there. That's why you need to find it from the commander. And over there, you have the different kind of, the slots. But let's go with the rectangle one first, and I will click OK. So we have different types, and also the true slot, which is another type of these which apply to every single of them. But let's go with the rectangle first, and I'll click OK. So the first thing you have to do, you have to select the plane you want to do operation. So I'm gonna choose that one, and it told me choose the horizontal reference. I'm gonna choose that line as a reference. You can see that's my reference. And now we're gonna create a rectangular slot for me. So let me put the length of the 10, the width of 5. Change this one to 20. I'm gonna go to 10, and also the depth of it. Let's put 20. Click OK. And you can see based on the dimension that I gave, it created that one for me. So that one was the 20, 10, and also the depth of it was 20. And now I need to position that. So these are the different ways. You can use the horizontal position, you can use the vertical one, you can use the perpendicular one. Let's go with the perpendicular one first. Let me see, and I'm gonna use this one with that one, and that distance I'm gonna change it to 30, and I'm gonna use that edge to this edge and change that one to 25. Okay, and when I'm okay, I will just press OK. And you can see that actually you created the rectangular slot for me, and everything is fine. I will just click cancel. You see that? It's a normal cut through. You may say I could easily draw an ellipse and do a extrude subtract. That's one of the reasons they removed the slot, but of course this one is easier. I would say even it's more professional. And if I put it to the isometric, if I go with static wireframe, you will see it there. Good. So let me do the another one. So let me delete this one, and I will go with a slot again, and I will choose the ball end. Choose where I want to operate, a line as a reference. I'm gonna pick that one, positioning it. So the length of it, let me put as the 20. The diameter, let me put it as the 5 again. And the depth of it, let me put as 15, for instance. Okay. And now I need to position that one. So I use the perpendicular, I use this one and that one. We'll change this one to 20. And I will position this edge with that one to 25, because I'm gonna bring it to the middle. I will click OK. And I'll click OK. You can see it brought it to the middle, and it's done. But what do you see there? The cut we have is like a ball goes through and cut it. Do you see? It's a kind of the ball ending for it. So if I show you the static wireframe, you see the difference there. And that's the ball and a slot you have there. So let me do the other one. Let me hide this one, and then we will come back to it later, because it's a slot I have to have. And also, if you then click on that, you can go to the change type. You can change that one to the US slot. Let's do it with that. And in here, you would be able to give the width of it, you would be able to give the depth of it, and also the corner radius in the exact corner. Let me change the width to the 5. So the corner radius, even I can make it as a 2.5. Hopefully, then I don't have any error. It's okay. I will create the new one. Sometimes you will get those error because the numbers you put doesn't match. It's okay. So we'll create another one. So create a slot. And then I will go with the U1. Choose the face I want to operate. Choose the reference. I'm gonna pick that one, but of course you can put any of those. Let me this time I use the other one to see the difference. I'm gonna pick this one and reference. Now I'm gonna choose this one. So the shape I get is from there. The width of it, let me put 10. The depth of it, let me put 20. The corner radius, let me put as the 1.5. And then let me put the 5. This one hopefully doesn't show the error, but then the length of that one, slot distance less than or equal to the width. Let's see what's the reason actually gives me that error. So that's the width of it, and I'm gonna have 10 is okay, depth is okay. The length of it, oh sorry, the width and length. So length should be 20. And the corner, it should be okay. Yes, okay. So you will have the width of it, the length of it, the height of it once you want to cut, and also the radius, because that's one which we are using as the inner radius. And let me use the positioning. So I'm gonna use these two again. And 12, it's okay. Let me change it to 20 so it comes a little bit in the middle. So we'll choose this one and that one, and I will change that one to 20 as well. I'll click OK. And you can see that was the radius which we were talking about, the radius inner, that's radius. And you can see it's like a U shape goes inside and do a cut. So that's this one. And something I wanted to mention, let me try the other one as well, and I will come back to this one because I wanted to teach you the true all as well. Let me do one more time, and this time we go with a TSLA. TSLA is basically you will have like a kind of T-shaped cut. Let me choose that one as a reference. So then because it's a T shape, you have two different set of dimensions, the top and the bottom. The top one is the smaller one, the bottom one is the bigger one. So let me go with the top one. Let me change that to the 10. Then you will have, how much does it need to go? I will change this one to the 5. The bottom width, it's the bigger one. I will change this one to 15. The bottom width, let's keep it as 5. And the total length are gonna have as the top width, bottom width should be okay. And oh, there, this one, the length. And let me make it as 20. Okay. So let me position. I'm fine. Let me okay with that one, and I will click. So what you see there is like a T-shaped one. Let me see whether I can show it to you here. Do you see that? So you would have two set of the dimensions. The one actually which is bigger, and the top one which was the smaller. That's why you had the two set of the information over there. The top one and the bottom one. And the top was telling me the error because the length wasn't matching the one that actually I had on the top. And that's this one as well. Let me delete that, and I will go with the other one, the dovetail one. Choose the reference. So let me change the width of it to the 5, the depth of it to the 10, and the total length to the 15. Positioning I'm fine, but of course you can always go there and change that. And if I click there, you can see this is how I have the dovetail one. So you would have the kind of angular one based on the angle that I gave there. And you see it over there. So let me delete this one, and now I'm gonna do a kind of normal one. Let me go with the rectangular one. We'll go click this one and use that positioning. I'll use those dimensions. I'll click OK. Okay. So what you can see, that's a normal rectangular slot. If I double click here, I can go to the change type, and now I'm gonna go ahead with this exact same one, but I'm gonna use the true slot. This is quite common. This is the method that is quite common to use a true slot, and let's see what happens. So the true slot, I don't know why I didn't pick it up. Let me do it again. True slot actually cut it from the both pieces. And from this face, I want to do a cut. So because that's a true, it will tell you from where you want to do a cut. So I will say from that face to this face. I'll click OK and OK. So you can see that's a true slot. So we'll do it one more time. That was the reason it actually didn't let me to use a true slot, because I didn't define the face where you want to operate. So let me delete this one. I will do it one more time for you. That's the same thing for any other slot if you want to use the true slot. So go with whatever type of slot you're looking for. I'm going to go with the rectangular one. And now you tick the true slot. So like before, you have to select the plane that you want to operate. I'm going to pick that one. You need to pick a horizontal reference. I'm going to pick that one. And now the software asks me, select the starting true face, where you want that actually true all start. I will choose this one. Where you want the true face should end, and they should be parallel. So you should be either those two or that two. They should be always parallel. And then you put the width of the rectangle you're looking for, the depth of it. And of course, you can be able to position that. And because that's true, it shows it bigger, but you can position that as well. I click OK. And you can see that's a true all. Basically, because I just said from that face to the other face, I want to have a true all slot there. So that's for the slot. The other thing I've tried, so I've used it last time, but I didn't explain it. That was the edge blend. So the edge blend is the one that actually using SolidWorks. They're familiar with the filleting. So basically the edge blend is the filleting, but Siemens call it the edge blend. And in order to do that, what I can do, I can click here. And now I have to choose where I want to have that edge blend. I'll pick this one. And you can see that I can put the radius that I'm looking for. Let's change one to 15, for instance. And you can see that's the radius I have there. And you have, so these are the two different methods of calculation. You can have it as a kind of conic one. We said it's become like a kind of conic shape. Then so you give the boundary radius and a conic radius. So you would have two. I will tell you what's the difference. Here you will see that you're giving the boundary radius, and also you're giving the kind of center of it. But of course, the common one is a circle one. We just give the normal. So the circle one is a normal filleting, basically. Just give the radius. And again, you have the other option as well to use the G1, which is tangent, or G2, which is a curvature. Again, normally we use, tangent, unless it's something actually is specified. I'll click OK. And that's the edge blend. So I will do it one more time. But this time we're gonna choose multiple edges. So I use this one, I'll pick that one, I'll pick the other one, and you can see that actually it automatically make the side for me, and I can go ahead and choose all of the edges that I'm looking for to have that one. And if I click OK, you can see that this is where I had the edge blends. So edge blends, they are quite simple to do. Is it clear? Is it clear? Should I move on? The recording. You're welcome. Great. So what I asked you to do was just doing the first tutorial. And in order to do the first tutorial, so once you look at to the picture of it, you will say, okay, then you can divide into the different segments. You might say, okay, I will design the base first, then I will design the top one here, then I will make these two extrudes, create a hole on top of that, create 4 holes in here, and this is basically what the tutorial is saying. There's another way, of course, you can say that you will be able to make it a full rectangular shape box and then do a US slot here or do a cut. But of course, with the normal sketch, you would be able to do it, and that's why the instruction says like that. So let me show it to you. I will go back to every single of them, and let's see what it says. So what you need to do, you need to sketch something like that. It's quite simple. So these are some set of lines, and a dimension, you get it from the instruction, from the drafting. Actually, it's available in the tutorial. And then it's a normal extrude. So let me hide those. Yeah, this one is just a normal extrude. And the extrude that I use is a symmetrical value. So 70 from each direction. And if you go there, so 140, because I wanted to use the symmetrical one, 70 direction extrude one side, 70 on the other side. And this is what I've done. And then once I've done the extrude in here, I came and do that sketch, which is this one. I came and just create that sketch. So basically what I've done is the one full line, and the length of it, it's exactly the same as actually what's the extrude you have. A line on the top, and I created the full circle and another circle, and then I created another circle. And what I've done, I went to where actually you define the geometric constraints, and then put a tangent to make sure they are tangent. That's why you're seeing that sign. And I've done the filleting. That's why you don't see the rest. And then you do extrude, and this is the extrude you've done. The extrude we've done for those two. You see that? One extrude, the other one. And the rest is just quite simple. So once you do that, we create a simple hole. I will show you to you what I've used for here. So it's a simple hole with a diameter of 30, and it's a true body. So I didn't put any of that. You just go and cut everything. And one more hole over there. And at the end, I use the simple hole in here. And I've used the pattern feature. So if you remember the pattern feature that I've covered, so you copy the same pattern you have in the different directions. Or you could technically create the full holes at the same time, but I've used the pattern feature to make it easier. So the reason I'm not going through it, because it takes time. If I want to do that, it takes time. But what I will do, I will upload the file for you. So let me make a note to make sure I actually upload the file for you. please go through the file, and then you will be able to see every single stage of that. So basically, you need to come back to every single stage and hide them. Good. So before we go to the second tutorial, this one is really simple. The only tricky part was just this sketch, and the second one, which as I said, so you will create a line, and then these two, the way actually you had to think that actually these are the three actual circles which they become tangent to each other. But the rest is just quite simple, and then you need to just follow the instruction which is available, and then I will also upload this file for you as well. So before we move on with the other tutorial for today, I'm gonna teach you ribs function as well. I think that would be useful to do. So in order to do that, let me go and create a new file. Okay, so let's say we have that, cube, and we're gonna do a flooring over there, or make a wall inside, which we call it the ribs. So what I need to do, I can go to the command function, I can type ribs, and first function is rib. So basically it tells me if I want to find it, I will go to the feature, I will go to the more, and then I will find it in design feature. So the reason I use the command finder quite often, because in every update, the Siemens NX try to move around these features, but the easiest ones, whenever you don't find it, just go with the command finder. So in order to create that one, I have to have a sketch. In order to have that sketch, I need to have a plane. So before I do that function or that feature, let me create a plane. And because I'm gonna create a ribs exactly in the middle, what I need to do, I'm gonna create a middle in between. And I'll go to the datum plane. I'll go with the bisector. This is what we covered last week, if you remember. I'll create a plane in between, and it's exactly between those two planes, and it's a bisector plane. So I'll go to the rib again. And now here, if I click on the sketch selection, it will let me to choose the plane. I'm gonna choose this one, and I will choose on plane. I'll click OK. So now the software lets me to a sketch. So let me do a sketch here from here to, let's say 40, done. And then I will do another one. I will do it like that. Yes, I know, because these two, they are vertical. It doesn't. Let me get rid of that. Yes. Okay, so I was over defining. Let me do a fillet to make it look nicer. You don't have to do the fillet. It's just, you need to have a sketch. And then once you finish the sketch, let's see what happens. It automatically created a wall for me. So I can use it the perpendicular to the section plane. It gives me something like a wall. And if I give to the parallel, it will give me a floor. Perpendicular to the section plane, parallel to the section plane. Also, I would be able to change the thickness of it as well. So let's change this one to 5. And you will be able to see the thickness has been increased. Even I can zoom in, and then I can use these arrows for the thickness. I'll click OK. And you can see this is what I've created. If in case you want to edit that, you will go and double click. So let me go to the curve, and you can see that actually I've created the 3 curves there. Let me use only one curve, and let's see what happens. So I'm gonna just go to here, go curve, because I use the fillet technique. It doesn't let me to do, but let me see whether it lets me to do that. Okay. So let me go to the sketch selection that I have. And now what I'm gonna do, I'm gonna get rid of this one. And let's say I'm gonna create something like that. Okay. Now in here, I'm gonna just have one here. And we go to the curve. I want a single curve. Okay. Let's see what happened if I just pick the single curve. It automatically try to extend that line to the next wall. So this is when you do the one curve. I can have it as a perpendicular. You see the full or the flooring. And if I pick the another one, so I can go to the curve. And if I pick the other one, it actually close that for me. Whenever you wanna untick something in the Siemens NX, you can hold the shift and pick the curve you don't want, and it automatically remove that one for you. So these are the ribs that I wanted to cover. I know because I've done the fillet. It was telling me, do you know that actually you remove the fillet? Okay, so was it clear? Do you want me to go with the second tutorial? So resume the recording. Great. So the way you need to do that, it's basically you need to think about it in the second tutorial, that what are the section you need to start. So as I mentioned earlier, you need to have the base, and then you do a sketch, extrude, and then you find that plane, you sketch the circle, you extrude it to make the cylinder, and then you sketch on top of this plane two different sketches, two different extrude, and these are all the holes that you need to create. This one is a simple hole, these are the concept board one. So let's see how I've done that. So first you have the sketch, and it's quite simple. So you get you make kind of, in a square shape by the 105 and 105, and these are all fillets that I've used with the filleting function in here. So once I've done that, I went and do the extrude, and extrude with the distance of the 12. So technically it's extrude of the 12, and I click OK. So once I've done that one, then I went and create that sketch. So choose that plane, and I made the circle with a diameter of 44. Then I extruded that one, which is that. So I extruded it with the length of 96. You see now I have one extrude, and that's the other extrude. And make sure you use the unite as the boolean, because you want this part to be attached to the other part. So I covered boolean into the previous sessions. Once you've done that, I need to pick that plane on the top and do a sketch on that. So what you do, just go to the sketch, pick the plane you want, and that's the plane that I want. And what I've done, I created that. So you can create either a curve here, or you can make the full circle and then do a cut, but I created a curve here, and it automatically make it as a kind of a tangent for me, because these two circles, they have the same diameter. You can use the concentric or tangent. It automatically software do that for you. And then you make the line and a line and connect it together, and make sure this one and this one are vertical and this one is horizontal. Software should do it automatically for you, but the one that actually I was doing didn't give me that option, so I had to manually put that one as a perpendicular. And once you've done that, then you use the extrude. So you extrude that design with the length of 76, and you repeat one more time with another sketch. So the same plane, but a different sketch. You have 32 and 30. You make them make sure these lines are horizontal, and they have or either perpendicular to this line. And You connect them with the curve. The curve should have the same radius or diameter of the main one. And then you do another extrude. So technically, you cover the majority of it. Once you reach to that stage, you need to have a simple hole on the top. This is a normal simple without any cylindrical bottom, so you don't have any kind of cone tip at the end. So that's why I put 0 and a depth of the 96. And it's a subtract because we are removing the part. It automatically finds it as a subtract for you because that's the hole. And then I went there and created a hole. I positioned the point with what the tutorial gave me. So the 15 from that edge and 20 from this edge. And once I've done that, I use pattern, or you can do it one more time. So I use pattern with that direction, the pitch distance of 30. And the same things for that one. So I created a hole. 15 is what the tutorial gave me with a diameter of 10. I use the pattern feature to have one more of that with the pitch distance of 22. And then at the end, I use the contact board hole. And the point that I use here, it's automatic software gave me the reason that I went with that point, because if you remember that actually once I've done the fillet, it automatically created that point for me. If you don't have that point, then you would be able to specify the point based on the dimension the tutorial gave you. But you should already have those points because of the fillet you have. So the seaboard diameter is 22 and 10, which is what you will get from here. So if you zoom, you see that actually these are the contact board ones that actually tells you. You have 4 with the diameter of a 10. The contact board one, you see that sign there? Do you see that sign? The sign there, which means that actually it's the contact board and the diameter is 20, and you will have the depth of the 2 that you need to put there. And that's the seaboard diameter 20, seaboard depth is 2. It's basically how you read those one. I know I could use pattern, but I decided to have 4 of that. So what I've done for you, because as I mentioned, it takes time for me to go and do it in a session. I uploaded the file that I created it. So again, if you remember the tutorials, to have access them, what you do, you go to your module homepage, you go to the design, communication, 3D modeling. What you're doing, it's the parametric modeling techniques. And if you scroll down, there's a section participating in seminar and tutorials. If you go to the tutorial files and NX models, and what we are covering today is the chapter 6. That's the presentation, which will tell you every single stage of what you need to do, and also whatever actually I taught you today. And even while you were waiting, I've also uploaded the files for you as well. So these are the tutorials that I've done. 2 files, you can download them. And there are also an exercises as well. If in case you want to practice, it's really good. These are a little bit more difficult to doing. You would be able to do those exercises as well. And these files are ready to use for the Siemens NX. Great. So that was it for me today. May I know whether you have any questions before actually we end the session? Thank you so much for staying that long with me with the today's session. That was the 4th session of the tutorial. So as I mentioned, I uploaded all the files and presentation files. Please go through of them. And if in case you have a question, you can drop me an email, or you can ask it to the next tutorial session. Thank you so much and have a lovely evening. Thank you.